Okay, hello everyone, and this is week 2. And this week we will learn about fundamental difference between SI and CI engine. What is SI? Means spark ignition, which is working on petrol or gasoline engine, and CI means compression ignition engine, which is working on diesel. So we'll basically discuss about the basic difference between SI and CI engine, and the second one, main components of reciprocating IC engine. Reciprocating IC engine, where piston, connecting rod, crankshaft. We will learn the basic components of IC engine one by one. And the third one is about IC engine terminologies. So in engine, which terminologies means like a stroke or some formulas about how to calculate that dia of the cylinder or the piston dia or something like else. And the last one to study the basic topic about IC engine. What is the basic difference between two-stroke and four-stroke engine, two-stroke in petrol or two-stroke in diesel? Each of them we will discuss. Okay. So if you want to discuss about classification, we already know the classification. This is a part of the classification of IC engine. Before we are going to start learning about engine, first I would like to share a video about the engine. What is an engine? This is recalling a revision of your week 1. Okay, in this video you will learn about how car engine work. So engine, it's talking about the engine, then you will understand the classification of engine. Okay, first of all, learn about engine.
A car engine generates power from the expansion of compressed air in a contained cylinder with the help of fuel. That is why it's called as an internal combustion engine. Before getting into the working, let's see the main parts involved in the working of an engine. First, the crankshaft. This is the part which converts the linear motion of the piston to a rotational force. Next, the pistons and the piston rods. The pistons will be pushed down by the expansion of compressed air, and turns the crankshaft. And the valves, which controls the flow of air and fuel into the cylinders. These valves are driven by the intake camshaft, and the exhaust camshaft, and the camshafts are driven by the crank itself, using a timing belt. There will be idler pulleys, and a tensioner pulley, to hold the belt tight in place. This here is the internal structure of a 4-stroke, inline 4-cylinder, DOHC engine, which is commonly found in most hatchback and sedan cars. A 4-stroke engine should pass through 4 different strokes, to complete one cycle to produce power. They are intake, compression, power, and exhaust stroke. The crank to camshaft ratio is 2:1, which means it will take 2 crank revolutions to complete 1 camshaft revolution. And the camshafts are designed in a responsive manner to open or close based on the corresponding strokes of each cylinder. Let's take a look at a single cylinder and see how a 4-stroke engine works in detail. In order to ignite the air-fuel mixture, a spark plug is used. This will ignite the compressed air-fuel mixture with the help of an electrical spark. We will take it down by each stroke. The intake stroke. The inlet valve opens and the downward movement of the piston creates a suction. This pulls the air-fuel mixture into the cylinder. Once the air-fuel mixture is in the cylinder, compression stroke begins compressing the mixture. At this time both inlet and outlet valves stays closed. At the end of compression stroke, the air-fuel mixture is ignited by the spark plug. The explosion exerts pressure and pushes the piston down. This is the power stroke which produces power to the crank. At the exhaust stroke, the outlet valves opens and the piston pushes out the burned gas. The cycle starts again from intake stroke, keeping the engine running and produces power. For a carburetor engine, the air and fuel are mixed inside the carburetor assembly, and fed to the cylinders. In the case of a fuel-injected engine, the fuel is injected into the intake manifold, or directly into the cylinders. Since only a power stroke produces power, you may wonder how the engine turns continuously. Well, the answer is in the crank itself. The flywheel and the crank counterweights provides momentum, which keeps the crankshaft from stopping immediately. For a 4-cylinder engine, considering any time instance, one cylinder is always in power stroke, which produces more power and less vibrations comparing to a single-cylinder engine. And that is how a car engine produces power in simple. Thanks for watching, and
ओके बेसिकली आपने देखा कि ये हाउ कार इंजन पे इसने बात की कि इंजन कैसे वर्किंग कर रही है, फिर उसमें 4 स्ट्रोक पे चले गए, किस तरीके से 4 स्ट्रोक डिफाइन करते हैं। अगर आप पेट्रोल की बात करेंगे, फ्यूल मिक्सचर अगर डीजल पे हैं तो इंजेक्टेड फ्यूल लगा रहे हैं उनका, तो उसमें आपने देखा कनेक्टिंग और कैम शाफ्ट हर चीज़ के उसमें टर्मिनोलॉजीज के बारे में इसने बताया आपको। तो ये आई थिंक ये आपको कवर हो गया। इसमें मेन कंपोनेंट्स ऑफ रेसिप्रोकेटिंग आईसी इंजन अबाउट वीडियो में किस तरीके से रेसिप्रोकेटिंग आईसी इंजन। सो फंडामेंटल डिफरेंस बिटवीन एसआई एंड सीआई इंजन जो अब हम बात करेंगे बेसिकली कि एक्चुअली स्पार्क इग्निशन एंड कंप्रेशन इग्निशन पे क्या डिफरेंस है। देयर आर 2 काइंड्स ऑफ इंटरनल कंबशन इंजन currently in production. Number one is spark ignition, which is we can call gasoline engine as SI engine. The compression ignition, sorry, the compression ignition, which is about diesel engine, CI engine. A spark ignition for first one is about spark ignition, gasoline and compression ignition, diesel engine. Two, different engines differ in how they supply and ignite the fuel. Different now the supply of fuel and ignition of the fuel are very different in both cases. Okay, in a spark ignition engine, the fuel is mixed with air and then induced into the cylinder during the intake process. After the piston compresses the fuel air mixture, the spark ignites it, causing combustion. The expansion of the combustion gases pushes the piston during the power stroke. So basically आपने वीडियो में देखा और जो थ्योरी लिखी हुई है आपको समझ में भी आ रही है बैकग्राउंड में की बात किस पे हो रही है। And a diesel engine only air is inducted into the engine and then compressed. Diesel engine then sprays the fuel into the hot compressed air. Only air is compressed where in diesel engine. Hot spray compressed air में जब हम fuel करेंगे spray, so at a suitable measure rate, causing it to ignite. तो ignition वहाँ पे spark नहीं होता, basically cause इस phenomena से होता है कि आप compressed air में आप fuel ignite करें, spray करें, तो वहाँ से ignition होती है। बेसिकली आपने पिक्चर्स पे देखा 4 स्ट्रोक क्यों मैं यहाँ पे कह रहा हूँ आपको फॉर नॉलेज के लिए कि यहाँ पे वेल्व्स हैं। वेल्व्स और डिजाइन की हम बात करते हैं कि सिंगल सिलेंडर 4 स्ट्रोक की बात है। अगर मैं आपको पिक्चर्स दूँ और मैं पूछूँ 2 स्ट्रोक और 4 स्ट्रोक, तो 2 स्ट्रोक में पोर्ट्स होते हैं नॉर्मली और ये 4 स्ट्रोक में जो है वेल्व सिस्टम लगा होता है। स्पार्क इग्निशन इंजन जहाँ पे आप गैसोलीन पेट्रोल और जो स्पार्क देख सकते हैं। सो एयर introduction air pre-mixed with fuel enters the cylinder. Pre-mixed means carburetor से आपकी जो air और fuel mixture जो carburetor का काम है supply देना air और fuel mixture proper जो है आपकी engine को engine और engine से inlet valve से, तो air pre-mixed with fuel enters the cylinder. Second one, air fuel mixture. Not you can say fuel mixture, just you can say air fuel mixture is ignited through a spark plug. Ignited क्यों होता है compressed होने के बाद। Fuel can be either injected in the ports, अब आप inject कर सकते हैं अगर ignition है, अगर वो इस तरीके से ignition in the ports, or can be mixed with air using carburetor. आप यहाँ से inject करें fuel को या carburetor से आपकी मर्जी, ये system है किसी classification में, and generally have lower compression ratio. ऐसा engines में आपको compression ratio lower मिलेगा। compression ratio क्या है हम डिफाइन करेंगे कंप्रेशन रेशियो एक्चुअली है क्या। बेसिकली कंप्रेशन रेशियो में आपको बताऊं द वॉल्यूम जो पिस्टन आपका नीचे आ रहा है और उसको कंप्रेस कर रहा है, कितना एयर फ्यूल मिक्सचर जो है इसने सक किया। मीन्स आप जैसे आपने सिरिंज से आपने कितना आपने वॉल्यूम ऑफ जो है मेडिसिन आप इस सक की एंड उसको कंप्रेस की उस पे उसका एक्चुअली कंप्रेशन रेशियो द रेशियो ऑफ सम intake to the inlet means the ratio of volume is charge volume to the and discharge volume. So हम डिस्कस करेंगे इस स्लाइड पे. तो बेसिकली कंप्रेशन रेशियो की डेफिनेशन वहाँ पे लिखी हुई where and generally the fuel is gasoline or gasoline पे SI engine काम करती है. How about CI engine? So CI engine आपने देखा तो बेसिकली डीजल पे फोर स्ट्रोक की वेल से और स्पार्क में ही यहाँ पे फ्यूल जो इंजेक्टर है. क्या बात है. कंप्रेस इग्निशन इंजन. CI means compression ignition engine. Only air is inducted into the cylinder. Fuel is injected directly just before the combustion process. Fuel is auto-ignited at a higher pressure and high temperature. Okay, phenomena जो auto-ignited होगा high pressure and high temperature में. Sorry, diesel fuel injection system. Diesel fuel injection. Diesel में fuel कैसे injection pump, delivery pipes and fuel injector nozzles लगी होंगी. So compression ratio उसमें जो है डीजल में हाई मिलेगा आपको, कंप्रेस करता है वॉल्यूम. जनरली द फ्यूल इज अ डीजल हम यूज करते हैं. बेसिक डिफरेंस. So there's again difference between SI and CI engine. The spark ignition are those types of engine where the combustion of the fuel with the help of a spark plug. In this type of engine, the air fuel mixture comes from the carburetor and enters to the engine cylinder through the valves, and then fuel is compressed in the compression stroke. Finally, a spark is given by a spark plug to ignite the air fuel mixture and get power stroke. Okay, तो आपने देखा कि ये हम जो थ्योरी में लिखा है और बेसिकली हमें समझ में आ रहा है कि बेसिकली हम बात किस पे कर रहे हैं. And how about CI engine, compression engine? The engine where the rise in temperature and pressure during the compression is sufficient to cause spontaneous ignition of the fuel. In this type of engine, only air is compressed in the engine cylinder. After the compression, the temperature and pressure of the air are rising up and sufficient enough to burn the fuel straight by fuel injector. Okay, difference between SI and CI engine. So SI petroleum, gasoline or gasoline working करता है auto cycle पे, means auto constant volume heat addition. अब constant volume heat addition क्या है, एक process है. आप उसमें thermodynamics में topic करेंगे auto cycle. Then it works on diesel. और diesel जो काम करती है constant pressure heat addition पे होती है. तो constant volume constant होगा, heat addition वहाँ पे होगी, और ये constant pressure होगा, heat addition होगी. During the intake or suction process, air and fuel are used, and during the intake or suction, only air is used. The fuel is supplied by carburetor. The fuel is supplied by injector. The starting of this engine is easy. The starting is really difficult compared with SI engine. It is used in small vehicles. It is used in heavy vehicles. Less noise produces. It produces high noises. The maintenance cost is low. The maintenance cost is high. So basic difference आपने देखा इसमें. And again we have another source, basically the difference between petrol and diesel engine. Auto cycle पे works on diesel. Petrol is used as a fuel. Diesel is used as a fuel. Air और फ्यूल देते हैं, ओनली एयर देते हैं आप सेक्शन स्ट्रोक में. लोअर कंप्रेशन रेशियो है, रेंज जो है आपको याद करनी पड़ेगी, 6 to 10 पेट्रोल में होती है. हाई कंप्रेशन रेशियो मींस 14 to 20. अब कंप्रेशन रेशियो है, रेशियो है. अब वॉल्यूम में हम देखेंगे कि रेशियो हम वॉल्यूम की बात करें, कितना स्ट्रोक उसने सक किया और कितना स्ट्रोक जो है उसने एक्सपांड किया, मींस एक्सटेंशन एक्सपांड एग्जॉस्ट किया केसेस में. Okay, means कितना पावर आपको मिला. Well, we will discuss. The compressed charge is ignited by spark plug. The fuel injector is used in diesel engine. High engine speed about 3000 rpm. Low to medium engine speed ranging from 50,000 to rpm आपको 15,000 rpm में. Thermal efficiency is lower due to lower compression. Thermal efficiency is higher due to compression ratio high. Lesser in weight because maximum pressure and temperature is less. Heavier in weight because maximum pressure and temperature is high. Less costlier, more costlier. Maintenance cost is slightly higher. Easier starting in cold weather. It's difficult to start in cold weather. running cost higher because petrol is costlier, running cost is less because diesel. तो आपने देखा कि ये भी डिफरेंसेस थे, ये भी डिफरेंस थे। बेसिकली आपको समझाने का था कि पेट्रोल और सीआई इंजन की डिफरेंसेस क्या हैं। तो हमने आपने देखा कि ये कितनी नॉलेजफुल थी कि भाई थ्योरी में आपको कैसे दिखना है डिफरेंस बिटवीन। तो जिस तरीके से हमने देखा कि स्पार्क इग्निशन एंड पेट्रोल डीजल इंजन की डिफरेंस बिटवीन को, तो आई हैव अ वीडियो, आई वुड लाइक टू शेयर अ वीडियो. Please watch this video about difference between spark compression ignition engine.
Explain the differences between spark and compression ignition engines. We know that spark ignition engine is the engine in which combustion takes place with the help of a spark produced by the spark plug. Here, combustion is a constant volume process. Also, we know that compression ignition engine is the engine in which combustion takes place with the help of the heat of compression. Here, combustion is a constant pressure process. The key parameters used for comparing the two engines are basic cycle, type of fuel, injection of fuel, ignition process, compression ratio, speed, thermal efficiency, and weight. Now let us compare spark and compressed engines on these parameters one by one. Spark ignition engine works on the basis of Otto cycle or constant volume heat addition cycle, whereas compressed ignition engine works on the basis of diesel cycle or constant pressure heat addition cycle. Spark ignition engine uses petrol as the working fuel. Petrol is a highly volatile fuel and has a high self-ignition temperature. Whereas compressed ignition engine uses diesel as the working fuel. Diesel is a non-volatile fuel and has a low self-ignition temperature. In spark ignition engine, a mixture of air and fuel is introduced in the suction stroke. Thus, it consists of a carburetor for mixing the air and fuel. Whereas in compressed ignition engine, fuel is injected directly into the combustion chamber at high pressure. Thus, it consists of a fuel pump and a fuel injector. In spark ignition engine, ignition process is carried out with the help of a spark plug, which ignites the compressed air-fuel mixture. Whereas in compressed ignition engine, self-ignition occurs due to high temperature of air because of high compression. Here, spark plug and ignition system are not required. In spark ignition engine, compression ratio varies from 6 to 10. Here, upper limit of the compression ratio is determined by anti-knock quality of the fuel. Whereas in compressed ignition engine, compression ratio varies from 16 to 20. Here, upper limit of the compression ratio is determined by weight increase of the engine. Spark ignition engines are high-speed engines due to their light weight and homogeneous combustion. Whereas compressed ignition engines are low-speed engines due to their heavy weight and heterogeneous combustion. Due to lower compression ratio, maximum value of thermal efficiency is lower in spark ignition engines. Whereas due to higher compression ratio, maximum value of thermal efficiency is higher in compressed ignition engines. Spark ignition engines are generally lighter in weight due to lower peak pressures. Whereas compressed ignition engines are generally heavier in weight due to higher peak pressures. Related terms are
ओके बेसिकली आपने देखा कि किस तरीके से जो है आईसी इंजन की सीआई एंड एसआई इंजन को डिफरेंस किया और दिस वीडियो आई होप के बहुत नॉलेजफुल होगी आपके लिए. Okay, we have another video regarding the differences between petrol and diesel engine. Please watch this video.
Petrol and diesel engines. We all know that diesel engines are lower revving and more fuel efficient than petrol engines, but do you know exactly how and why they're different? If not, then let this video be your ultimate guide. Petrol, aka gasoline, and diesel engines operate on the same 4-stroke cycle. This starts with the intake stroke where the piston descends, sucking air into the cylinder through open air intake valves as fuel is injected. This is followed by the compression stroke where the valves close and the piston goes back up the cylinder to compress the air and fuel mixture. The third step is the power stroke where the mixture is ignited to force the piston back down the cylinder, and then the final exhaust stroke occurs where the ignited fuel and air mixture is pushed back out of the cylinder by the piston through the exhaust valves. Where petrol and diesel engines differ is how they ignite the air and fuel. To understand the difference, we need to understand the self-ignition temperature. This is the temperature at which an air-fuel mixture will ignite without the use of a spark plug purely due to compression. It's this compression that allows the air and fuel mixture to ignite in a diesel engine without the need of a spark, because the greater compression, the higher the temperature. That's why diesel engines have higher compression ratios compared with petrol engines that don't compress the air and fuel mixture to the point of ignition. If you don't know what a compression ratio is, let me quickly explain. Simply put, it's the ratio of the maximum to minimum volume in the cylinder. So a ratio of 10:1 means that when the piston is at its lowest point, there is 10 times as much volume as when it's at its highest point. To give you an example of compression ratios, a 2015 VW Golf TSI has a compression ratio of 9.6:1, while a 2015 VW Golf TDI has a compression ratio of 16.2:1. Again, a diesel will have a higher compression ratio to ensure that the air and fuel mixture is compressed enough to the point of ignition, while a petrol engine uses less compression and is ignited by the spark plug. Though no longer true for all modern oil burners, another significant difference with a diesel versus petrol engine is that diesels lack a throttle body. This means that when you press on the accelerator pedal, the fuel injectors simply supply more diesel to create more power. Petrol or gasoline engines, on the other hand, require a throttle body. As you press on the accelerator pedal, you open up the throttle and allow more air to flow into the engine. More air means the injectors send in more fuel, and more fuel means more power. Where petrol and diesel engines differ again is how they're able to engine brake, where you lift off the throttle in gear to slow the car down. In a petrol vehicle, engine braking is achieved because as you lift off the throttle body closes, creating a vacuum between the throttle body and the cylinders to slow the car down. In a diesel engine vehicle with no throttle body, engine braking occurs during the compression stroke, where the exhaust valve is open to allow pressurized air to escape. And the reason engine braking with diesel engines is so loud is because you're hearing that compressed air leaving the exhaust. So why exactly are diesel engines more efficient than petrol engines? One of the many reasons is down to the fuel itself. Diesel is comprised of more long-chain hydrocarbons, which simply means it's got more energy than petrol. In fact, it contains about 15% more energy by volume, roughly 36.9 megajoules per litre compared to petrol's 33.7 megajoules per litre. Diesel engines are also more efficient because of the thermal efficiency gains you get from igniting the air with high compression, rather than a petrol engine's lower compression ratio that requires a spark for ignition. The higher compression ratio, longer stroke, and typically higher turbo boost pressure of a diesel also allows it to produce more torque at lower RPM than a petrol engine, meaning that less fuel is needed to move a car. Another reason why diesels are more fuel efficient is their tendency to be turbocharged, and that's because a turbo feeds compressed air into the cylinder, which helps the piston descend into the cylinder, therefore saving energy. So now that you know the inner workings of a petrol versus a diesel engine, which one are you a bigger fan of? Let us know in the comments below, and remember to give this video a lovely thumbs up.
तो बेसिकली आपने डिफरेंस बिटवीन पेट्रोल एंड डीजल इंजन में आपने देखा कि किस तरीके से डिफाइन करते हैं डिफरेंस बिटवीन एसआई एंड सीआई इंजन. और उसके साथ साथ हमने देखा कि किस तरह से डिफरेंस बिटवीन पेट्रोल इंजन डीजल इंजन दिखा था एंड मूव ऑन टॉपिक मेन कंपोनेंट्स अबाउट रेसिप्रोकेटिंग आईसी इंजन। मैंने आपको वीडियो इससे पहले जो इस पे वीक 2 स्टार्टिंग से जो वीडियो आपके साथ शेयर की उसमें हर मैकेनिज्म बताया क्या क्रैंक शाफ्ट का क्या मैकेनिज्म है, कैम शाफ्ट का क्या है। सो लेट्स स्टार्ट अबाउट सिलेंडर। सिलेंडर क्या है एक्चुअली? इट इज द मेन पार्ट ऑफ द इंजन इनसाइड which piston reciprocate to and fro. यहाँ से to and fro होती है। It should have high strength to withstand high pressure about 50 bar and temperature about 2000 centigrade. अब ये आप देखेंगे कितना withstand कर सकता है सिलेंडर इसमें टेम्परेचर एंड प्रेशर। The ordinary engine is made up of cast iron and heavy duty engines are made up of steel alloys or aluminum alloys. नॉर्मली जो है ना कास्ट आयरन, बाकी हैवी जो है उसमें हम देखें स्टील लॉयड एंड एल्यूमिनियम। इन द मल्टी सिलेंडर इंजन द सिलेंडर आर कास्ट इन वन ब्लॉक शोन एज अ सिलेंडर ब्लॉक। तो जो मल्टी सिलेंडर में तो सिलेंडर ब्लॉक हम कहते हैं। तो सिलेंडर आपने देखा कि एक जो है ना एक मेन कंपोनेंट्स ऑफ आईसी इंजन है। ओके, एंड देयर वी हैव अ सिलेंडर हेड। व्हाट इज द सिलेंडर हेड? Top end of the cylinder is covered by cylinder head. So cylinder head covered over which inlet and exhaust well spark plug or injector are mounted during cylinder head. A copper or asbestos gasket is provided between the engine cylinder and the engine cylinder head to make an airtight joint. यहाँ पे एक जो गैस की कॉपर वहाँ पे मिलेगी आपको जो airtight आप जो है ना रखेंगे between. And we have an piston, third one, transmit the force exerted by burning of charge to the connecting rod. Okay, this is correct. Usually made up of aluminum oil, which has a good heat conducting property and greater strength at higher temperature. Okay, and we have another piston rings. Normally, piston rings are these are housed in the circumferential grooves provided on the outer surface of the piston and made up of steel alloys, which retain elastic properties even at high temperature. Two types of rings, compression and oil rings. Compression rings is upper ring of the piston, which provides airtight seal to prevent leakage of the burnt gases into the lower portion. Oil rings is lower ring, which provides effective seal to prevent leakage of the oil into the engine cylinder. So normally आपने देखा दो रिंग्स होती हैं, एक कंप्रेशन रिंग्स होती है, वो नॉर्मली आपको यहाँ पे पिस्टन के यहाँ पे फर्स्ट वन पाई जाती है, ये फर्स्ट वन यहाँ पे, एंड देयर यू नो ये ऑयल रिंग्स जो है ऑयल लीकेज आपको पास में से प्रिवेंट करती है। एंड देयर वी हैव अ कनेक्टिंग रॉड। कनेक्टिंग रॉड किसे कहते हैं? कनेक्टिंग रॉड आप देख सकते हैं कनेक्टिंग रॉड। It converts reciprocating motion of the piston into circular motion of the crankshaft in the working stroke. The smaller end of the connecting rod is connected with the piston of gudgeon pin, and bigger end of the connecting rod is connected with the crankshaft. Okay, so crankshaft के साथ आपकी crankshaft लगेगी. Okay, so move on. We have with a crank pin. The special steel alloys or aluminum alloys are used for the manufacture of connecting rod. Alloys से बनी जाती है aluminum alloys से. There we have a crankshaft. अब crankshaft क्या है? इस picture में आप देखें crankshaft. Crankshaft we have it converts reciprocal motion of the piston into rotating motion with the help of connecting rod. The special steel alloys are used for the manufacturing of the crankshaft. It consists of eccentric motion called crank. Okay, and we have a crankcase. Case आप देख सकते हैं crankcase आपको ये बता रहा है. We have it houses cylinder and crankshaft of the IC engine and also serves as a sump for the lubricant and oil. यहाँ पे आपको oil भी मिलेगा. And we have a flywheel. Flywheel आप देखें कि यहाँ पे crankshaft के साथ अलग ही flywheel. It is a big wheel mounted on the crankshaft. Whose function is to maintain its speed constant. The function speed it is done by storing excess energy during the power stroke, which is returned during the other stroke. Okay? So आपने देखा कि ये components थे और हमने second part of this week complete कर दिया है। तो इसके साथ साथ हमारे third one topic है terminology। अब जब आप IC इंजन यूज करते हैं तो उसमें हम टर्मिनोलॉजी जो आप प्रॉब्लम सॉल्व करेंगे तो आप सिलेंडर बोर को डी से डिनोट करें। सिलेंडर बोर जो आप सिलेंडर देखिए, आप सिलेंडर बोर क्या कहते हैं? बोर द नॉमिनल इनर डायमीटर ऑफ द वर्किंग सिलेंडर। तो इनर डायमीटर आपका जो सिलेंडर उसको डी से। पिस्टन एरिया है द एरिया ऑफ द सर्किल ऑफ द डायमीटर इक्वल टू द सिलेंडर बोर, अब पिस्टन का एरिया आपको मालूम करना है, जो सर्किल है उसका एरिया मालूम, सर्किल ऑफ द डायमीटर इक्वल टू सिलेंडर बोर, and stroke, which is we can call L, the dominant distance between the throw which a working piston moves between two successive reversal of its direction of motion. Means stroke means from top to bottom, and we have a dead center. That's the position of the working piston and the moving parts which are mechanically connected to it at the moment when the direction of the piston motion is reversed at either end point of the stroke. How we have a bottom dead center and top dead center. Bottom means dead center. Dead center when the piston is nearest to the crankshaft. कैसे? जब piston आपका नीचे आएगा, ये आपका bottom and this is top. कितनी top dead center पे जा सकता है? तो अब देख सकते हैं bottom and top dead center. Dead center when the position is farther from the crankshaft. Okay, displacement volume or shift volume, which is known by Vs, the nominal volume generated by the working piston when traveling from one end center to the next one, and given its shift volume area into L. Shift volume is stroke volume, which is L is equal to stroke length and D the bore. So shift area we know is the bore cylinder pi by D square and into L. Okay. So यहाँ से आप देख सकते हैं एरिया एंड शिफ्ट वॉल्यूम, अगर कोई प्रॉब्लम दे तो आप इस प्रॉब्लम इस इक्वेशन से आप प्रॉब्लम सॉल्व कर सकते हैं. And we have a clearance volume which is denoted by VC, the nominal volume of the space on the combustion side of the piston at the top dead center. अब clearance volume क्या है? Actually clearance volume यहाँ पे एक वॉल्यूम होगा जो clearance जो स्मॉल वॉल्यूम एक छोटा जो है ना स्पेस दिया जाएगा, तो वहां पे आप देखते हैं नॉमिनल वॉल्यूम ऑफ द स्पेस ऑफ द कंबशन साइड on the combustion side of the piston at the top of the dead center. The top of the dead center ये clearance volume. Cylinder volume, which कि आप सिलेंडर का वॉल्यूम कितना, आप सिलेंडर ये वॉल्यूम कितना चार्ज कर रहा है, तो टोटल वॉल्यूम सिलेंडर. V, which is denoted by shift volume plus compressed volume. अब shift volume इतना है कि compressed volume यहाँ तक. ओके, सो आप देख सकते हैं कि टोटल वॉल्यूम आपका यहाँ से मालूम मिल सकता है. एंड वी हैव अ कंप्रेशन रेशियो, जो हमने देखा कि हर वक्त इंजन और पेट्रोल में कंप्रेशन रेशियो इज हाई लो. तो कंप्रेशन स्विफ्ट वॉल्यूम, स्विफ्ट कितना कंप्रेस हुआ और स्विफ्ट वॉल्यूम में कितना कंप्रेस डिवाइडेड बाय कंप्रेस वॉल्यूम. सो नॉर्मली पेट्रोलियम इंजीनियरिंग का जो गैस ऑयल कंप्रेशन लो होता है और डीजल का हाई, जो हमने वीडियोस में देखा. एंड वी हैव कंप्रेशन रेशियो, अगेन द रेशियो ऑफ टोटल सिलेंडर वॉल्यूम, टोटल सिलेंडर वॉल्यूम इसका टोटल वॉल्यूम टू द क्लियरेंस वॉल्यूम. ये जो है तो इसका और कंप्रेशन रेशियो. अब ये जो है तो रेशियो है, तो टोटल सिलेंडर वॉल्यूम VS ओवर. So our compression cylinder volume at the bottom center, cylinder volume top dead center. तो ये रेशियो है, आप इसमें प्लस करें तो you will get this formula again. And for petrol engine, compression ratio from 6 to 10, and for diesel 14 to 20. ये डीजल के लिए बहुत है. Piston speed आपको मालूम करनी है, it's average speed of the piston, and it's equal to 2 length of the stroke and number of revolution by n speed crankshaft. Okay, revolution per second. Piston speed, which is denoted by 2 per second, length and the n is in RPM. So normally आपने देखा कि किस तरीके से आपने जो टर्मिनोलॉजीज आपने देखी, कंपोनेंट्स किस तरीके से काम आते हैं. So our last topic is about 2-stroke and 4-stroke. Okay, so जिस तरीके से आपने देखा कि we have already done fundamental difference between SI and CI engine and main components of reciprocating IC engine and IC terminology. So I would like to share a video about main components of reciprocating IC engine. Please watch this video.
Hi everyone. Welcome to CAD Mania. This is the second video of internal combustion engine components. Today we will discuss about some other parts of internal combustion engine. In the first video we have learned about the following parts: cylinder block, cylinder head, crankcase, piston, and piston rings. If you had not watched the first video, please watch it, link is given in the description of video. So let's start the video. Connecting rod. Here you can see the image of connecting rod. There are two ends of connecting rod. One is known as big end and other as small end. Big end is connected to the crankshafts and the small end is connected to the piston by use of piston pin. It transmits the reciprocatory motion of piston to rotary crank. Connecting rod is made up of low-carbon steel 30C8 material. The manufacturing method that is used to mate is forging followed by heat treatment. Now we will learn about the crankshaft. It receives the thrust supplied by piston to connecting rod. The main function of crankshaft is to transform reciprocating motion into a rotary motion. The shape and size of crankshaft depends on the number and arrangement of cylinders. The crankshaft is mounted in bearings so that it can rotate freely. It is made up by the material of 37C15 alloy steel by using casting process. Now we will learn about the flywheel. Here you can see the image of flywheel. It is a rotating mass used as an energy storing device. The main function of flywheel is to rotate the shaft during preparatory stroke. Flywheel also makes the rotation of crankshaft more uniform. Cast iron is used to make the flywheel. Manufacturing method used to make it is casting. Now we will learn about the spark plug. The main function of a spark plug is to conduct the high potential from the ignition system into the combustion chamber. It provided the proper gap across which spark is produced by applying high voltage to ignite the mixture in the ignition chamber. Spark plug is used in petrol engine. Gap of spark plug lies between 0.6 mm to 1.8 mm. Here our 10th part of internal combustion engine is carburetor. The function of a carburetor is to atomize and meter the liquid fuel and mix it with the air as it enters the induction system of the engine. It maintains the fuel-air proportion under all conditions of operation appropriate to the conditions. Now we will learn about the valve. It is used to allow the flow into and out of the cylinder at proper time in the cycle. Valve are made up of forged steel. In two-stroke engine ports is used instead of valve. Remaining parts we will discuss in our third video. Subscribe the channel to watch more videos like this.
Okay, जिस तरीके से आपने देखा कि ये मेन कंपोनेंट्स थे आप आईसी इंजन के और हमें प्रेजेंटेशन में हमें कवर किए थे और उसके साथ मैंने वीडियो शेयर की. देन वी हैव आईसी इंजन टर्मिनोलॉजीज. हमने टर्मिनोलॉजीज प्रेजेंटेशन में भी कवर की. ये बोर एंड so we have a video. Please watch this. Okay, we have this video for your entertainment. I hope you will enjoy this video. Terminology of IC, and I hope you will get some knowledge from this video. Please watch.
Of IC engines. At the end of this lesson, you'll be able to explain the various terminologies of IC engines. Good morning, Sam. Good morning, sir. What are you doing? Sir, I'm watching the working of the IC engine of a tractor. It is interesting and also easy to understand. Okay, so can you tell me what is the name of the part which keeps moving up and down? It is called as piston, sir? Good. Now tell me, what is this? It is the diameter of the cylinder, and it is called as bore. Ah, yes, bore. Okay, leave it. Can you explain its working? Yes, sir. At first, the piston moves up from the top dead center, or TDC. Yes, sir. Yes, sir. From top dead center to the lower bottom dead center, or BDC. Yes, sir. Bottom dead center. It is called as stroke. Yes, sir. Okay, answer this question. What is clearance volume? Clearance volume. It is the distance covered by the piston from top dead center to the bottom dead center, sir. It is not clearance volume, it is swept volume. Were you really watching the working video, Sam? Yes, sir. I know the working of this engine really well, sir. I know that, but you don't know how to describe it in words. Yes, sir, you are right. I do have a problem with that. Then you should concentrate on the terminologies used here. Sam, learning is of no use at all if you don't know the terminologies. Knowing the terminologies will help you to solve the problems in your lesson. And also to do well in the viva voce at the end of your term or in an interview. Not only that, this knowledge is critical, as you need to know the terminologies to convey your ideas to your friends at your college and workplace. Oh, okay, sir. I did not realize that terminologies were that important. Will you please teach me, sir? Yes, no problem. I will explain to you the terminologies of the IC engine. Thank you, sir. This is the engine block, which provides the foundation for all the engine's components. The inside diameter of the cylinder is called bore. It is measured in millimeters. The topmost position of the piston towards the cover end side of the cylinder is called top dead center, or TDC. In horizontal engines, this is known as inner dead center. The lowest position of the piston towards the crank end of the cylinder is called bottom dead center, or BDC. In horizontal engines, this is known as outer dead center. The linear distance along the cylinder axis between top dead center and bottom dead center is called as stroke. An engine with equal bore diameter and stroke length is called a square engine. If stroke length is twice the size of the bore diameter, then the engine is called an undersquare engine. If the bore diameter is twice the size and the stroke length, then the engine is called an oversquare engine. Clearance volume. When the piston is at top dead center, the volume contained in the cylinder above the top of the piston is called as clearance volume. But, sir, why can't we move the piston up to the extreme top? That is a good question. Zero clearance volume is not recommended because if it doesn't have a clearance volume, it is difficult for the flame to expand. Hence, the flame needs a minimum space. The volume swept through by the piston between top dead center and bottom dead center is called swept volume. It is also called as piston displacement. Total volume is equal to the sum of swept volume and clearance volume. The rate at which the piston moves inside the cylinder is known as piston speed. This rate is not constant. Piston speed is equal to 2 into length of the stroke and speed of the engine. That is 2 into L into N. Engine speed is nothing but the crankshaft speed. These you have just learned are based on the working features of the IC engine. Now, I will explain to you the terminologies based on the performance parameters. We will start with compression ratio. It is the ratio of total cylinder volume to clearance volume. The rate at which the engine can be worked is measured in horsepower, that is HP. 1 HP is equivalent to 4,500 kilograms meter per minute. And in terms of watts, it's 746 watts. The power that is actually developed in the engine cylinder is called indicated horsepower. It is given as IHP is equal to PLANK divided by 4,500 into 2, where P is the average pressure produced in the combustion chamber, which is called as indicated mean effective pressure. L is the stroke length. A is the area of cylinder. N is the speed at crankshaft. And K is the number of cylinders in the engine. Most tractor engines are designed with 2 to 4 cylinders. The indicated power produced in the cylinder of the engine cannot be achieved completely by the crankshaft. There will be some loss due to friction, so the crankshaft never receives the whole power generated in the engine cylinder. The horsepower available in the crankshaft is known as brake horsepower. bhp is equal to 2 phi nt divided by 4,500 into 2 in terms of kilogram meter per minute, where n is the speed at crankshaft and t is the torque, which is the force that causes the rotational motion. Now, I will explain to you some of the additional work that can be done using this horsepower. In most of the modern tractors, a rotating shaft is coupled at the back in order to drive other machines like hay balers, generators, hydraulic pumps, etc. This is called as power takeoff, or PTO. The PTO horsepower is around 80 to 85% of tractor engine power. Soil preparation is necessary for crop cultivation and is usually carried out by using a tillage machine. Usually, this machine is attached with the tractor using a drawbar pin, which is pulled from the center of the tractor. This power of a tractor measured at the end of the drawbar is called as drawbar power. This power is also used to pull loads. I hope you have understood the working of an IC engine, Sam. Yes, sir. Now I understand the working of the IC engine better. Good. Summary. In this lesson, you have learned about the terminologies based on constructional and working features of IC engines, the terminologies based on performance parameters of IC engines.
ओके जिस तरीके से आपने देखा टर्मिनोलॉजीज ऑफ आईसी इंजन बड़ी इंटरेस्टिंग वीडियो थी और ब्रेक हॉर्स पावर इंडिकेटर हॉर्स पावर मीन इफेक्टिव प्रेशर और जिस तरीके से दूसरे टर्मिनोलॉजीज आपको फार्मूलेज बताए आई होप कि ये वीडियो आपके इंफॉर्मेटिव नॉलेज के लिए बहुत इम्पोर्टेंट होगी ओके So now come to our last topic is about to study the main topic about IC two-stroke and four-stroke engine. Okay, so move to about four-stroke and two-stroke engine. Let's start from here. Okay, this figure actually shows a cycle of operation of four-stroke engine. Cycle means four-stroke. There are strokes added to the piston. Move from top dead center to bottom dead center for one stroke. Okay? So suction stroke, we can say induction stroke. Suction stroke means piston move from top TDC dead center to bottom dead center. You can see. Okay, air and fuel mixture enters and the exhaust valve closed. So in this second one is compression stroke. We have compressed we have to compress, air fuel mixture because this is the petrol air fuel and this is the spark SI engine. And the third stroke is about combustion and expansion stroke. So after some temperature arise, and this is spark ignites, and we have expansion again down. Then there we have an exhaust stroke. So an exhaust stroke, in the exhaust gases goes, out and piston moves upward. So cycle of operation in four-stroke engine. Basically, a cycle of operation completed in four-stroke of the pistons or two revolutions of the piston. Okay, so two revolution of the crankshaft. Here it is a mistake. Okay. So in number one, you can see in the first suction stroke means suction valve open, exhaust valve closed. Charge consisting of the fresh air mixed with the fuel is drawn into cylinder due to the vacuum pressure created by the movement of the piston from TDC to BDC. We already know the top dead center and bottom dead center was TDC and BDC. So compression stroke, second one is about compression stroke. Compression stroke, both valves closed. Fresh charge is compressed into the clearance volume by the return stroke of the piston and ignited by the spark for the combustion. Hence, pressure and temperature is increased due to the combustion of the fuel. Third one is expansion stroke. Both valves closed. High pressure of burn gases forces the piston towards PDC, and hence power is obtained at the crankshaft. And we have exhaust stroke. Exhaust stroke means exhaust valve open, suction valve closed, burn gases expel burn gases expel out due to the movement of piston from BDC to DDC. Okay. And we have another figure in a picture of four-stroke engine, four-stroke in a spark condition. So another type of figure, you can see in books like inlet valve, exhaust valve, and we know TC, okay, total radius volume, and BDC, bottom center, and top dead center. Okay. So majority of reciprocating engines are based on four-stroke cycle. Four-stroke means intake, compression, power, and exhaust. One power stroke completes in 2 revolutions of crank, applicable to both SI and CI engines. Okay. So basically, both applicable here. This for SI and CI engine. We already discussed this SI and CI engine. So introduction, we want to again discuss about four-stroke engine. So four-stroke in SI engine, compressing the mechanical cycle. Okay, intake stroke start at piston TDC and ends at BDC. It's intake. Okay, and fresh air mixture. When fresh mixture is drawn in the cylinder. Compression stroke start when both valves are closed. Mixture is compressed to a small fraction of its initial volume, and pressure increases. Power expansion stroke, we can high temperature, high pressure gases pushes the piston down and force the cranks to rotate. Exhaust stroke, remaining burn gases exist as cylinder. Internal combustion engine, about four-stroke engine. If you are using four-stroke engine, so advantages: dedicated lubrication systems makes to engine more wear resistance. We have a lubrication system. Battery efficient, that two-stroke engine. Okay, and no oil in fuel, less pollution. So battery efficiency of the two-stroke engine. We don't know right now two-stroke engine, so we will discuss after this four-stroke engine. Drawbacks: complicated constructions, should work in horizontal position due to lubrication. So drawbacks some are for four-stroke engine. Okay, internal combustion engine, about four-stroke. First air intake. This is the process, and normally he classified. Normally we have four strokes. So the four process: suction, compression, and power, and exhaust. So intake is suction, and compression, and fuel injection, and this one power. Okay, the same. Okay, and we have an exhaust intake normally. Okay. So how about two-stroke engine? I already told you in two-stroke engine there is no valves. So in two-stroke engine, we normally in this side, petrol air mixture, is going inside, enters, from this port, and when the piston position is from coming from, top to end. Okay. So this when the piston move position goes up, okay, and then as all the piston moves down, so basically we have a spark plug, piston, and same process, but we have a ports. So let's discuss two-stroke engine. No piston stroke for suction and exhaust operation. Stroke, here is no stroke for suction and exhaust operation. Okay. Suction is accomplished by air compressed in the crankcase or by a blower. Okay, suction. How we will discuss. Induction of compressed air removes dead products of combustion through exhaust port. Okay, so induction of compressed air removes dead product of combustion through exhaust port. Transfer port. Here is transfer port. We have a transfer port. Okay, you can see in design. And transfer port is there to be supplied the fresh charge into the combustion chamber, Figure 3 represent operation of two-stroke engine. So in this figure, you can see two-stroke engine. Normally, we have a simple in this same like this. Basically, design and piston moves up and down. It takes two stroke, in a one revolution. It's work in a two-stroke. जैसा कि मैंने आपको बताया कि इसमें यहाँ पे नो पिस्टन स्ट्रोक है सेक्शन पर एग्जॉस्ट सेक्शन जो है आपकी एयर कंप्रेस्ड होती है तो एक कंप्लीट विद एयर कंप्रेशन करेक्ट स्ट्रोक में दो चीजें साथ साथ एक स्ट्रोक होती रहती है वो कैसे हम देखेंगे इस वीडियो में वेल अगेन वुड लाइक टू शेयर अबाउट टू स्ट्रोक इंजन कैसे डिफाइन कर सकते हैं टू स्ट्रोक इंजन मींस कंप्रेशन स्ट्रोक एंड पावर और एक्सपांशन स्ट्रोक हम उसमें फोर स्ट्रोक में कह रहे थे कि कंप्रेशन है एक्सपांशन है और इग्निशन है समोर लाइक फोर स्ट्रोक अब इसमें है क्या है जो कंप्रेशन होती है और पावर होती है उसको कहते हैं आप एक्सपांशन स्ट्रोक है there's no suction stroke there's no exhaust stroke okay one power stroke complete in one revolution of crankshaft और उसमें क्या one power stroke come into four stroke में जो piston motion control opening and closing of valves so piston की जो movement है वो actually control जो उसमें जो valves की थी actually valves control openings of valves okay and petrol ports जो हमारे ports हैं control the exhaust and inlet flow while the piston is close to BDC. जिस तरीके से हमने कहा कि piston up and down में होगा तो the ports control the exhaust, okay? Exhaust जितनी निकालनी and inlet flows जो inlet कितना while the piston is close to bottom dead center. Normally इसमें जो है two stroke engine के हवाले से आपको डिस्कस कर रहा है and again देखें आपके इसके ports एक fuel air mixture is drawn to crankcase okay and this is a burn fuel mixture is goes up outside from the cylinder okay and you can see that in two-stroke engine we have ports on opposite directions so inlet and exit ports are in opposite direction so this is another design of two-stroke engine okay so two-stroke engine applicable to both SI and CI engine. You will find SI and Spark and CI engine. Two-stroke also working on diesel. High power to weight ratio. We will find higher power. You will get more power to weight. Simple valve design. ये simple इसमें designing है और complicated नहीं. Compression stroke and power stroke as we know from two-stroke. Compression stroke means compresses the cylinder. Contents and draws fresh charge into the crankcase. अब कैसे इसका मैकेनिज्म हम उसमें वीडियो में देखेंगे ज्यादा एनिमेशंस में यू विल गेट मोर नॉलेज कि किस तरीके से एयर फ्यूल मिक्सचर ट्रांसफर पोर्ट से आ रहा है किस तरीके से हेल्प करता है ट्रांसफर पोर्ट इन टू स्ट्रोक इंजन में सो इनिशिएशन ऑफ कंबशन नियर टीडीसी अब कंप्रेशन स्ट्रोक में जो है ना कंबशन कब होती है जब जो है टीडीसी पे होता है अब आपका इनिशिएशन एंड पावर एक्सपेंशन स्ट्रोक एग्जॉस्ट पोर्ट्स एंड इनटेक पोर्ट्स आर अनकवर्ड sequentially induction of fresh charge compressed in the crankcase okay so normally जब भी आप टू स्ट्रोक को डिफाइन करेंगे तो आप देखते हैं कि किस तरीके से और कहां से हम इसको स्टार्ट करें टू स्ट्रोक इंजन को तो वही पिक्चर है नॉर्मली पिक्चर में आप देख सकते हैं कि ये आपको बताना चाह रहा है कि किस तरीके से वर्किंग करा टू स्ट्रोक इंजन सो अगर आप टू स्ट्रोक इंजन यूज कर रहे हैं इस तरीके से तो उसके एडवांटेजेस एंड डिसएडवांटेजेस भी होते हैं सो एडवांटेजेस क्या है लेक ऑफ वेल्व्स जो मैंने कहा इसमें वेल्व्स होती है व्हिच सप्लाई सिंप्लीफाइज कंस्ट्रक्शन एंड लोअर वेट जब वो कंस्ट्रक्शन भी उसकी जो है ना पोर्ट्स में आ गई फायर once every revolution means hell work during one power one revolution में power which gives a significant power boost can work in any orientation good power to weight ratio the drawbacks lack of dedicated lubrication system makes the engine to wear faster lubrication system में problem है necessity of oil addition into the fuel तो जरूरी होता है कि आप ऑयल एडिशन इनटू ऑयल डालें जब फ्यूल जहां आप डालते हैं लो एफिशिएंसी and produce a lot of pollution इस इंजन से आपको पोल्यूशन से बहुत ज्यादा मिलेंगी तो अब आपने देखा कि एडवांटेजेस ऑफ डीजल इंजन तो आपने पेट्रोल इंजन देखी, डीजल इंजन। सो एडवांटेजेस ऑफ डीजल इंजन क्या है? सेल्फ इग्नाइशन। डीजल इंजन की अगर मैं पूछूं तो एडवांटेजेस, तो सेल्फ इग्निशन है, विदाउट इलेक्ट्रिसिटी स्पार्क प्लग। अब डीजल में नहीं, बेटर एफिशिएंसी मिलेगी, रिलायबिलिटी, हाई ड्यूरेबिलिटी, सप्लाइड विथ वर्स फ्यूल्स। एंड ड्रॉबैक्स डीजल इंजन की क्या है कि वही मोर एक्सपेंसिव प्रोडक्शन, मोर वेट है, लाउडर है, लोअर रिवोल्यूशन है। सो इंटरनल कंबशन इंजन के डीजल के किस तरह से वर्किंग करते हैं, किस तरह से जो है फ्यूल स्प्रे होता है उसमें, तो फ्यूल इंजेक्टर होते हैं। तो दिस इज अ फ्यूल पैसेज एंड इंजेक्टर बॉडी, इलेक्ट्रोमैग्नेटिक कॉइल होता है, रिटर्न स्प्रिंग। तो ये इंजेक्टर के काम इन डीजल में आता है। तो कंपैरिजन अबाउट 4 स्ट्रोक एंड 2 स्ट्रोक इंजन में, तो राइट नाउ डिफरेंस क्या है कि हमने जो पढ़ा और उसके साथ अपने वीडियो भी देखेंगे क्या इंफॉर्मेशन है अबाउट 2 स्ट्रोक एंड 4 स्ट्रोक इंजन के हवाले से। वेल, 4 स्ट्रोक ऑफ द पिस्टन and 2 revolution of the crankshaft. 2 stroke of the piston and 1 revolution of the crankshaft. 1 power stroke in every 2 revolution of the crankshaft. 1 power stroke in each revolution of the crankshaft. Heavier flywheel due to non-uniform turning movement. Lighter flywheel due to more uniform turning movement. Power produced is less. Theoretically, power produced is twice than the 4-stroke engine for same size. Light and compact. Here it is heavy and bulky, okay? Lesser cooling and lubrication required, greater cooling and lubrication requirement here. So we have another few points. Lesser rate of wear and tear, higher rate of wear and tear, contains valve and valve mechanisms, contain ports arrangement, high initial cost, cheaper initial cost, and volumetric efficiency is more due to greater time of induction. Volumetric efficiency less due to lesser time of induction. Volumetric efficiency, thermal efficiency, we will discuss in the next coming classes. Okay, thermal efficiency is high and also part load efficiency better. Thermal efficiency is low and part load efficiency lesser. It is used where efficiency is important. It is used where low cost, compactness, and lightweight are important. For example, important where efficiency important when XR buses, trucks, efficiency important tractors, industrial engines, aeroplanes, power generation, where you can find efficiency important. And if you are done X lawn movers, scooters, motorcycles, mopeds, propulsion ships, where you find like a weight or low cost, something like. So here's a few another source difference between 4-stroke engine and 2-stroke engine. So 4-piston moves, 4-piston stroke required to complete 1 cycle, 4-piston stroke. I told you in the first time only 2-piston stroke required to complete 1 cycle. And to complete revolution of crankshaft is required to complete 1 cycle. Only 1 complete revolution of crankshaft is required to complete 1 cycle, equal to half of the speed of engine crankshaft, which is number of power stroke per minute, n, and equal to speed of engine crankshaft number of power stroke, which is n equal to n. Power is developed in every alternate revolution of crankshaft. Power is developed in each revolution of crankshaft, hence for same cylinder. The power is developed in every alternate revolution, hence heavy flywheel is required. The power is developed in every revolution, hence lighter flywheel is required. These engines are heavier, larger, and require more space, and these engines are lighter and more compact, and you require less space. The inlet and exhaust valves are required, and they are operated by a valve operating mechanism. In place of valve, ports are used which opens and close by motion of piston itself. Lubricating oil consumption is less. Lubricating oil consumption more because lubricating oil is mixed with fuel. Thermal efficiency is higher, less thermal efficiency. Mechanical efficiency low because of more number of moving parts. Mechanical efficiency high because of less number of moving parts. These engines are used basically in high power applications where more space is available, like car, truck, tractor, etc. These engines are used in basically low power applications where less space is available, like mopeds, scooter, motorcycle, etc. So basically आपने देखा कि ये difference between two stroke और four stroke थे इंजन के. So इसके साथ साथ हम आपको वीडियो जो है शेयर करना चाह रहे हैं कि जो नॉलेज के लिए किस तरीके से एनिमेशन से आप फोर स्ट्रोक और टू स्ट्रोक को समझ सकते हैं. Okay, I would like to share a video about four-stroke engine. किस तरीके से four-stroke working करता है. आप please देखें इसमें maybe after this video you will be able to describe four-stroke engine. Please watch this video.
A basic lesson in the fundamentals of a four-stroke EFI gas engine may be helpful to your understanding of Mercury products. Here are the basic components of every four-stroke gas engine: a piston, a connecting rod, a crankshaft. As the piston travels up and down in the cylinder, this lateral motion is turned into a rotating motion at the crankshaft. The longer the stroke of the piston, the larger the displacement of gas and air occurs in the cylinder. To propel that piston, we need to ignite a tiny bit of gas and a whole lot of air. This creates expansion inside the cylinder. The fuel delivery system consists of an air intake manifold, valves, intake and exhaust, a fuel injector, and a spark plug. A four-stroke engine is called a four-stroke because 4 up and down motions are needed to complete the cycle. In the first stroke, the piston travels downward as the intake valve opens and a mixture of air from the atmosphere and a metered amount of gas from the electronic fuel injector enter the cylinder. This is called the intake stroke. On the second stroke, the piston travels upward, compressing the air and fuel to make a highly combustible mixture. This is called the compression stroke. At this point, the spark plug fires, sending the piston downward from the expansion of the air and gas mixture. This is the combustion stroke. The fourth stroke is the exhaust stroke. As the piston travels upward, the exhaust valve opens to release the burned air-fuel mixture. When the piston reaches the top of this stroke, the intake valve opens and the cycle begins all over again. It takes 1 up and down motion or 2 strokes of the piston to create 1 revolution of the crankshaft. RPMs, or revolutions per minute, is how many times the crankshaft rotates within that minute. At wide open throttle, the crankshaft may turn at 5,000 RPMs, or a dizzyingly 83 times per second. Meanwhile, the piston traveled up and down 166 times in that same second. Want to see how fast that is? Now, that's fast. Let's see it again. Amazingly, the four-stroke EFI engine does this smoothly, quietly, and reliably for years and years of operation.
Okay, जिस तरीके से आपने देखा कि फोर स्ट्रोक इंजन किस तरीके से डिफाइन किया, सेक्शनल स्ट्रोक, एक्सपांशन स्ट्रोक, पावर स्ट्रोक. Okay, इसके साथ साथ I would like to share a video about two-stroke and four-stroke engine. Please watch this video.
Two-stroke and four-stroke engine. In two-stroke engine, 1 revolution of crankshaft is equal to 1 power stroke. In four-stroke engine, 2 revolution of crankshaft is equal to 1 power stroke. Torque. Two-stroke engine generate high torque as compared to four-strokes engine. Four-stroke engine generates less torque due to 2 revolution of crankshaft between 1 power strokes. Method of inlet and outlet. Two-stroke engine use port to inlet and outlet of fuel. Four-stroke engine use valve to inlet and outlet. Weight of engine. Two-stroke engine are light in weight as compared to four-stroke engine. Two-stroke engine have lightweight flywheel as compared to four-stroke engine. Cost of engine. Two-stroke engine are less in cost than four-stroke. Method of cooling. Two-stroke engine is air-cooled. Four-stroke engine is water-cooled. Power-to-weight ratio. Two-stroke has high power-to-weight ratio. Four-stroke engines have less power-to-weight ratio. Efficiency of engine. Two-stroke engines are less efficient and generate more smoke. It has less thermal efficiency. Four-stroke engines are more efficient and generate less smoke. It has high thermal efficiency. Manufacturing of engine. Two-stroke engines are easy to manufacture. Four-stroke engines are hard to manufacture. Noise created by engine. Two-stroke engines create more noise as compared to four-stroke engine. Two-stroke engines have simple lubrication system whereas four-strokes have complex lubrication system. Wear and tear in parts. Two-stroke engines have more wear and tear in moving part as compared to four-stroke engine. Space occupied by engine. Two-stroke engines require less space as compared to four-stroke engine. Application. Two-stroke engines used in mopeds, scooters, motorcycles etc. Four-stroke engines used in cars, buses, trucks etc. Thanks for watching. Please like.
Okay, we have another video in Hindi to describe, two-stroke and four-stroke engine and animation. Please watch this video.
स्ट्रोक इंजन के डिफरेंस के बारे में। टू स्ट्रोक और फोर स्ट्रोक के डिफरेंस को हम 3 कैटेगरीज में डिवाइड करके देखेंगे, जिसमें से पहली है कंस्ट्रक्शनल डिफरेंस यानी उसकी बनावट के डिफरेंस, उसके बाद आएगा ऑपरेशनल डिफरेंस यानी उसके वर्किंग के टाइम जो डिफरेंस आते हैं वो, और लास्ट में होगा हैंडलिंग डिफरेंसेस यानी कि इंजन को यूज करते वक्त आने वाले डिफरेंसेस। तो शुरुआत करते हैं कंस्ट्रक्शनल डिफरेंस से। तो फोर स्ट्रोक इंजन के पिस्टन में ऑयल रिंग लगी होती है, जबकि टू स्ट्रोक इंजन के पिस्टन में ऑयल रिंग नहीं लगती। कमेंट करके हमें इसका रीजन बताना ना भूले। फोर स्ट्रोक इंजन में इनटेक और एग्जॉस्ट वाल्व होते हैं, जबकि टू स्ट्रोक इंजन में उनकी जरूरत नहीं पड़ती। टू स्ट्रोक इंजन का कंस्ट्रक्शन फोर स्ट्रोक इंजन से काफी सिंपल होता है, क्योंकि उसके अंदर पूरी की पूरी वाल्व ट्रेन नहीं होती। फोर स्ट्रोक इंजन में यूज होने वाले फ्लाईव्हील की साइज टू स्ट्रोक के फ्लाईव्हील से काफी बड़ी होती है, क्योंकि टू स्ट्रोक इंजन का वर्किंग काफी स्टेबल रहता है। टू स्ट्रोक इंजन में एडिशनल ट्रांसफर पोर्ट दिया जाता है, जो कि फोर स्ट्रोक इंजन में नहीं होता। कम कंपोनेंट होने के कारण टू स्ट्रोक इंजन फोर स्ट्रोक इंजन के मुकाबले वेट में काफी हल्का होता है। फोर स्ट्रोक इंजन में क्रैंक केस में सिर्फ ऑयल ही रहता है, जबकि टू स्ट्रोक इंजन में प्रीमिक्स लुब्रिकेशन सिस्टम होने के कारण क्रैंक केस में ऑयल और पेट्रोल दोनों रहते हैं। इन कंस्ट्रक्शनल डिफरेंस के बाद हम आते हैं वर्किंग डिफरेंस के ऊपर। तो टू स्ट्रोक इंजन में हर एक रेवोल्यूशन पर एक पावर स्ट्रोक होता है, जबकि फोर स्ट्रोक इंजन में हर 2 रेवोल्यूशन पर एक पावर स्ट्रोक होता है। इसी कारण जो टू स्ट्रोक इंजन है उसका पावर टू वेट रेशियो फोर स्ट्रोक इंजन के मुकाबले ज्यादा होता है। फोर स्ट्रोक इंजन की फ्यूल एफिशिएंसी टू स्ट्रोक इंजन से ज्यादा होती है, क्योंकि प्रैक्टिकली फोर स्ट्रोक इंजन के मुकाबले टू स्ट्रोक इंजन पर रेवोल्यूशन हाफ फ्यूल यूज करता है। टू स्ट्रोक इंजन में फ्रेश चार्ज एग्जॉस्ट गैस के साथ ऑलवेज मिक्स होता रहता है, जिसके कारण इंजन के परफॉर्मेंस डाउन होता है। पर यह प्रॉब्लम फोर स्ट्रोक इंजन में सेपरेट स्ट्रोक होने के कारण इतना नहीं आता। टू स्ट्रोक इंजन ज्यादा नॉइज प्रोड्यूस करता है फोर स्ट्रोक इंजन के मुकाबले, और इसका कारण है इंजन का कंस्ट्रक्शन। फोर स्ट्रोक इंजन ज्यादा थर्मल एफिशिएंट है टू स्ट्रोक के मुकाबले, क्योंकि फोर स्ट्रोक इंजन प्रैक्टिकली 2 रेवोल्यूशन पर एक पावर स्ट्रोक करता है, जबकि टू स्ट्रोक इंजन हर एक रेवोल्यूशन के ऊपर एक पावर स्ट्रोक करता है। टू स्ट्रोक इंजन नॉर्मली फोर स्ट्रोक के मुकाबले कम टेम्परेचर पर काम करता है, जिसके कारण इसे एयर कूल्ड रखा जाता है। यानी कि ऐसा कह सकते हैं कि कंपैरिजन में फोर स्ट्रोक इंजन ज्यादा गर्म होता है। टू स्ट्रोक इंजन में कम पार्ट्स होने के कारण फोर स्ट्रोक इंजन के मुकाबले कम फ्रिक्शन लॉस होता है। अब बात करते हैं हैंडलिंग डिफरेंसेस की, तो टू स्ट्रोक इंजन वाले व्हीकल में फ्यूल टैंक के अंदर आपको फ्यूल के साथ ऑयल डालना पड़ेगा, जबकि फोर स्ट्रोक इंजन वाले व्हीकल में आपको सिर्फ फ्यूल ही डालना है। टू स्ट्रोक इंजन का जो मैन्युफैक्चरिंग कॉस्ट है वो फोर स्ट्रोक इंजन से कम है, यानी कि हम ऐसा कह सकते हैं कि मार्केट में आपको टू स्ट्रोक इंजन फोर स्ट्रोक के मुकाबले सस्ते मिलेंगे। टू स्ट्रोक इंजन का मेंटेनेंस कम पार्ट्स होने की वजह से कम आता है, जबकि फोर स्ट्रोक इंजन का मेंटेनेंस टू स्ट्रोक के मुकाबले ज्यादा होता है। अगर आपको लगता है कि इस वीडियो में कोई पॉइंट मिस हुआ है या फिर उसे ऐड करने की जरूरत है, तो कमेंट में बताना ना भूले। तो दोस्तों,
Okay, we have another video about understanding two-stroke and four-stroke engine. Please watch this video.
You probably have some knowledge of how internal combustion engines work. They involve pistons, cams, explosions, etc. But you know the difference between two-stroke and four-stroke engines. Throughout the history of automotive design, there have existed two main types of gasoline-powered combustion engines: the two-cycle, or two-stroke, and the four-cycle, or four-stroke engine. As you may have guessed, the names of each engine suggest exactly how they operate. For an engine to complete combustion, there needs to be combustion of the air-gas mixture and expulsion through the exhaust port. The way this process is repeated varies between each engine type. A two-cycle engine completes a combustion and exhaust cycle in only 2 strokes of the piston, whereas a four-cycle engine takes 4 strokes of the piston, thus their names. For a four-cycle engine, there's a power stroke where the piston is down, which is caused by combustion of the fuel mixture. Then there's an exhaust stroke where the piston is up, which pushes the gas up and out of the engine. The following 2 strokes include an intake where the piston is down to draw in the fuel, and a compression stroke where the piston is up to start the process all over again. Examining this process closer yields the observation that the whole cycle is powered by the initial combustion stroke. This means that the combustion of the fuel mixture needs to impart enough power on the piston to allow it to rotate the crankshaft twice. A two-cycle engine, on the other hand, has much simpler mechanics, as it basically consolidates the different processes of a four-stroke engine. There is a power stroke, which also releases the exhaust after a certain amount of travel. Then an intake and compression stroke that draws in new fuel and completes combustion. These are the basic mechanics of each engine type, but both have significant advantages and disadvantages, which has ultimately led to a more widespread use of the four-stroke engine. Looking first at efficiency, a four-stroke engine achieves great efficiency due to the fact that nearly no fuel is wasted in the intake cycle. In other words, the fuel is drawn into a closed system. In a two-stroke engine, since the fuel is drawn in during a combined intake and compression stroke, the mechanics needed for this also means that some fuel can escape while being drawn into the cylinder, thus decreasing efficiency. Modern two-strokes use fuel injection, which increases increases their efficiency to levels close to 4 strokes. But generally, a 4-stroke can be much more efficient. Efficiency isn't everything, though. A 4-stroke is certainly more efficient, but they also weigh upwards of 50% more than a comparable 2-stroke engine. This weight is due to more complexity within the motor's mechanism, which also leads to significantly more moving parts in a 4-cycle engine. In terms of simpleness and easiness to fix, a 2-stroke engine easily wins out. The last main difference between these engine types is how oil is added to the engine. In a 2-stroke engine, the oil is typically mixed with the fuel, usually somewhere in a 50-to-1 to 20-to-1 range. This makes oil application fairly reliable, but it also means increased fuel cost and fuel modification when you buy it. A 4-cycle engine uses normal gasoline like your car, which also happens to be a 4-stroke engine, and the oil is injected from a separate reservoir. This eases the burden of fueling the engine up, but of course there's always the possibility that the fuel pump will break. All things considered, even with the drawbacks of the 4-stroke, 4-cycle engines maintain higher efficiency over 2-strokes and can produce more power than comparable 2-stroke engines. There have been cars made with 2-stroke engines, but they mostly died off in the early 1980s due to efficiency constraints. Modern 2-stroke engines are still produced for small watercraft and gardening equipment. Sometimes simple design, like the 2-stroke engine, doesn't always beat out more complex mechanics. Thanks for watching. If you enjoyed this video, you can watch more of our videos here.
बेसिकली आपने देखा किस तरीके से डिस्क्राइब कर रहे हैं डिफरेंट जो वीडियोस है. Okay, we have another one video about very interesting how 2-stroke on the 2-stroke engine working, how it works animation. So I hope this video you will enjoy. Please watch this video.
Two-stroke engines are still being used today, for example in go-karts, as they are lighter and more cost-effective than 4-stroke engines. We will explain a 2-stroke engine with a simple carburetor. The construction is similar to 4-stroke engines. The 2-stroke engine has one piston. The crankcase is used for the gas exchange. There are also a spark plug as well as intake and exhaust ports. A crucial difference is the presence of the transfer port. Let's take a closer look at the individual strokes. In the first stroke cycle, a fresh fuel-air mixture is drawn in via the intake port. It is shown here in red. It is added to the existing mixture in the crankcase. At the same time, the mixture is compressed in the combustion chamber and finally ignited by the spark plug. The second cycle starts. The hot air expands and presses the piston downwards, reducing the volume of the crankcase. Because of that, the mixture is forced into the combustion chamber. At the same time, the fresh mixture forces the exhaust fumes out. Now the cycle starts all over again. The volume reduction in the crankcase can be very easily explained using small spheres. The spheres represent the fresh mixture. The mixture is sucked into the crankcase through the piston moving upwards. When the piston then moves downwards, no additional fresh mixture flows in and compression takes place because the volume of the crankcase is decreased. As a result, the fresh mixture makes its way into the combustion chamber via the transfer port. The engine shown here operates according to the principle of cross-flow scavenging. Intake and exhaust port are on opposite sides. The deflector piston is formed in such a way that the incoming fresh mixture can successfully push out the exhaust fumes. Uniflow scavenging is another type of scavenging used. For example, in opposed piston engines, 2 pistons operate in only one cylinder. Here, one piston controls the fresh mixture flow, whereas the other controls the emission of exhaust fumes. This system is expensive and was used in tanks, but also frequently for large marine diesel engines. Modern engines uses loop scavenging, which is used, for example, in the famous Simpson mopeds. It is still used in many engines today. For the sake of simplicity, the crankcase and housing cover are not shown. There are various ports in the cylinder, including an inlet port. The fuel-air mixture is fed to the inlet port via the carburetor. The piston, moving up and down in the cylinder, opens and closes the inlet port consistently. When the inlet port is opened, the mixture is able to flow in. The mixture is then forced into the transfer ports by the piston. The piston closes the transfer ports and exhaust port when it travels upwards. It opens them when it travels downwards. Through the transfer ports, the fresh mixture is promoted to the cylinder and filled from the rear to the front. When the spark plug finally ignites the mixture, the piston is moved downwards, and fresh mixture is able to flow in. In this process, the fresh mixture pushes out the exhaust fumes.
ओके किस तरीके से आप जिस तरीके से आपने देखा कि 2 स्ट्रोक इंजन और एनिमेशन बड़ा इंटरेस्टिंग वीडियो थी आपके आपने एंजॉय की होगी इस वीडियो को ओके इन द लास्ट वी हैव अ लास्ट वीडियो रिगार्डिंग 4 स्ट्रोक मोटरसाइकिल एनिमेशन और लास्ट में हमने 2 स्ट्रोक को दिखा 4 स्ट्रोक को और नहीं देखा प्लीज पॉज दिस वीडियो स्मॉल वीडियो
As every rider knows, nothing beats the sense of freedom that comes from owning a motorcycle. But keeping riders on the road means that motorcycles must be as light and compact as possible. That's why the engine, clutch and gearbox are combined into one crankcase. Remove the engine case halves and the compactness of the engine and transmission are readily apparent. A closer look reveals the hundreds of intricate components that make up the engine and transmission. A motorcycle lubricant must be specially formulated to protect all of those components. Not just the engine, but also the gearbox, which is subjected to extremely high pressures. And the metal-to-metal sliding contacts in the valve train, which place constraints on the lubricant as well. As does the clutch, which also operates within the crankcase. The clutch, which is housed underneath the engine's side cover, consists of several fiber discs and steel plates. Here, the motorcycle lubricant must provide vital cooling, while allowing for friction to develop between plates and discs when engaged. Motorcycle lubricant must be pumped to all components to lubricate and remove heat. This includes the counterbalance, used to reduce vibration. The lubricant also plays a critical role in the operation of the transmission. The 2 shafts you see here, input and output, together with the gears and shifting mechanism, make up the transmission. The transmission performs the important role of transforming high-speed, low-torque engine power to low-speed, high-torque power for propelling a motorcycle. The cylinder, cylinder head, valves and piston are the components that are subject to the highest operating temperatures. Sufficient oil flow is critical to absorb heat energy and carry it away from these components. Additionally, oil must be formulated to resist oxidation and break down at the extreme temperatures which result from combustion. Unlike passenger car engines, where engine and driveline components are installed and lubricated separately, motorcycles house all these components with their specific and often competing lubrication requirements in a single unit. one lubricant is called upon to do it all. That's the challenge every motorcycle lubricant faces each time the engine directs energy through a network of shafts, clutches and gears and delivers consistent, useful power, all to propel the motorcycle as far as the rider's ambition will take him or her.
तो इस वीडियो में आपने जिस तरीके से देखा कि 4-stroke मोटरसाइकिल इंजन में लुब्रिकेशन का बड़ा इंपॉर्टेंट रोल है और बार-बार लुब्रिकेशन पे देखा जा रहा था. लेट्स कम्स टू आवर फाइनल डिस्कशन कि हमने प्रेजेंटेशन में लास्ट टॉपिक जो था हमारा 2-stroke एंड 4-stroke पेट्रोल हो या डीजल इंजन पे जो वर्किंग हो रहा है इस वीक पे हमने जो कवर किया बहुत अच्छी तरीके से हमने इस पे डिफाइन किया, डिस्क्राइब किया विद वीडियोस के साथ. आई होप कि आपने इस टॉपिक को बहुत सारा एंजॉय किया होगा और इस मेरे ख्याल से इस प्रेजेंटेशन में आपके रिगार्डिंग 2 क्वेश्चन और मोर देन 3 क्वेश्चन रिगार्डिंग पेपर से आप कर सकते हैं. इससे आईक्यू टेस्ट भी हो सकता है और बहुत सारे इंटरेस्टिंग क्वेश्चंस भी हो सकते हैं कि इस स्ट्रोक में क्या है हो सकता है क्या क्या होता है. तो नॉर्मली आप इसमें नॉलेज लें और इस वीडियो को देखें. मैंने आपके लिए बनाई है और प्लीज़ कोशिश करें कि इस वीडियो को देखें. जहां तक आपको कोई प्रॉब्लम हो प्लीज़ मुझसे पूछ सकते हैं. थैंक्स टू ऑल ऑफ यू.